Download this code from codegive.com, link in the description below. OK, let's dive deep into backend development and databases, covering essential concepts, technologies, and code examples to give you a solid understanding. This will be a comprehensive guide, so buckle up. Part 1, Introduction to Backend Development. 1. What is the backend? The backend, also known as the server side, is the engine that powers a web application or any digital platform. It handles data storage, processing, and logic, and it communicates with the frontend, user interface, to deliver a seamless experience. Think of it as the brain and nervous system behind the user-facing website or app. Key responsibilities of the backend **** data management *** storing, retrieving, updating, and deleting data from databases. ** business logic * implementing the core rules and algorithms of the application, example calculating prices, processing orders, handling user authentication. *API, application programming interface providing a way for the front-end and other applications to interact with the backend's functionality. Think of it as a contract that specifies how to request and receive data/services. *Security * protecting sensitive data, handling authentication and authorization, and preventing malicious attacks. Scalability and performance * ensuring the backend can handle increasing traffic and data volumes efficiently. 2. Backend technologies, popular choices. Programming languages **** Python ** popular due to its readability, extensive libraries, like Django and Flask, and versatility for data science and machine learning. JavaScript, Node.js allows you to use the same language, JavaScript, on both the front-end and backend, simplifying development and code sharing. Java * robust and scalable, widely used in enterprise applications. Frameworks include Spring Boot. C, .NET Microsoft's framework, well suited for Windows-centric environments. PHP * still used in many legacy systems, especially with frameworks like Laravel and Symfony. Go, Golang designed for concurrency and performance, often used for microservices and cloud-native applications. Ruby * known for its elegant syntax and the Ruby on Rails framework, which emphasizes convention over configuration. Web frameworks * built on top of programming languages. Python * Django, Flask, Fast API. JavaScript, Node.js Express.js, Nest.js, Koa. Java * Spring Boot, Jakarta EE, formerly Java EE. C, .NET ASP.NET Core. PHP * Laravel, Symfony, CodeIgniter. Go, Golang Jin, Echo, Fiber. Ruby * Ruby on Rails. Databases * we'll cover these in more detail later. Relational databases, SQL MySQL, PostgreSQL, Microsoft SQL Server, Oracle. NoSQL databases * MongoDB, Cassandra, Redis, Couchbase. Cloud platforms * AWS, Amazon Web Services offers a vast range of services, including compute, storage, databases, and more. Azure, Microsoft Azure Microsoft's cloud platform, tightly integrated with .NET. Google Cloud Platform, GCP Google's cloud platform, known for its expertise in data analytics and machine learning. Heroku a platform as a service, PaaS, that simplifies deployment and scaling. Netlify primarily for front-end hosting, but also provides backend functions, serverless. API architectures REST, representational state transfer, a widely used architectural style for designing networked applications. It uses standard HTTP methods, GET, POST, PUT, DELETE, to interact with resources. GraphQL a query language for APIs that allows clients to request only the data they need, improving efficiency. gRPC a high-performance, open-source RPC, remote procedure call, framework developed by Google. 3. A simple backend example, Python and Flask. Let's create a minimal hello, world, backend using Python and the Flask framework. Explanation 1 From Flask import Flask, JSON-IFA, imports the Flask class and the JSON-IFA function from the Flask library. JSON-IFA helps to convert Python data structures, like dictionaries, into JSON format, which is commonly used for APIs. 2 App equals Flask, __name__, creates an instance of the Flask class. The __name___ variable refers to the name of the current module. 3 At @appRoot, / this is a decorator that associates the hello_world function with the root URL, / When a user visits the root URL, Flask will execute the hello_world function. 4 Def hello_world, this is the function that will be executed when the root URL is accessed. It simply returns the string hello, world. 5 At @appRoot, /API/greet, methods equals get, defines an API endpoint at /API/greet that only accepts GET requests. 6 Def greet_API, returns a JSON response containing a greeting message. JSON-IFA is used to convert the Python dictionary into a JSON string. 7 If __name__ _main__, this is a common Python idiom that ensures the app run line is only executed when the script is run directly, not when it's imported as a module. 8 App run, debug equals true, starts the Flask development server. Debug equals true enables debug mode, which provides helpful error messages and automatically reloads the server when you make changes to the code. To run this example 1 Install Flask *pip install Flask. 2 Save the code save the code as appy, or any name you prefer. 3 Run the application Python appy. Now, open your web browser and go to http://127.0.0.1:5000/ you should see hello, world. http://127.0.0.1:5000/ API /greet you should see a JSON response, message, greetings from the backend. This is a very basic example, but it illustrates the fundamental principles of creating a backend with Flask, defining routes, URLs, handling requests, and returning responses. Part 2, Databases, Deep Dive. 1. What is a database? A database is an organized collection of data, typically stored and accessed electronically from a computer system. Databases are essential for almost every application that needs to store and manage information persistently. 2. Types of databases. Relational databases, SQL databases. Data is organized into tables with rows, records, and columns, fields. Relationships between tables are defined using foreign keys. They use SQL, structured query language, to query and manipulate data. Enforce data integrity through constraints, example primary keys, unique constraints, data type validation. Acid properties, atomicity, consistency, isolation, durability, ensure reliable transactions. Examples MySQL, PostgreSQL, Microsoft SQL Server, Oracle, SQLite. NoSQL databases, not only SQL databases. More flexible data models than relational databases. Do not typically use SQL for querying. Often designed for scalability and performance, especially for handling large volumes of unstructured or semi-structured data. Come in various flavors. Document databases store data as JSON-like documents, example MongoDB, Couchbase. Key value stores store data as key value pairs, example Redis, MEMC8. Column family stores store data in columns rather than rows, example Cassandra, HBase. Graph databases store data as nodes and relationships, example Neo4j. Examples MongoDB, Cassandra, Redis, Couchbase, Neo4j. 3. Relational databases, SQL, in detail. Tables the fundamental building blocks. Each table represents an entity, example users, products, orders. Rows, records each row represents a single instance of the entity, example a specific user, a particular product. Columns, fields each column represents an attribute of the entity, example user_ID, username, email, product_name, price. Primary key a unique identifier for each row in a table, example user_ID. Foreign key a column in one table that references the primary key of another table, establishing a relationship, example an orders table might have a user_ID column that references the users table. SQL, structured query language. SQL is the standard language for interacting with relational databases. Here are some essential SQL commands. Select, retrieves data from one or more tables. Insert, adds new rows to a table. Update, modifies existing rows in a table. Delete, removes rows from a table. Create table, creates a new table. Alter table, modifies the structure of an existing table, example add a column. Drop table, deletes a table. Example, MySQL. 4. NoSQL databases in detail, MongoDB. Let's focus on MongoDB as a popular example of a NoSQL document database. Documents data is stored as documents in JSON-like format, BSON in MongoDB. Documents can have varying structures within the same collection. Collections a collection is a group of documents. Think of it as similar to a table in a relational database, but without a fixed schema. No schema enforcement, schemaless you don't need to define a schema upfront. Each document can have its own unique structure. This offers flexibility but requires careful data management. Example, MongoDB with Python and PyMongo. Explanation 1 From PyMongo import Mongo client, imports the Mongo client class from the PyMongo driver. 2 Client equals Mongo client, mongodb/localhost 27017/ creates a connection to the MongoDB server. Replace mongodb/localhost 27017/ with your actual connection string if your MongoDB instance is running elsewhere. 3 DB equals client MyDatabase, accesses the database named MyDatabase. If the database doesn't exist, MongoDB will create it when you insert data. 4 users equals DB users, accesses the collection named users. If the collection doesn't exist, MongoDB will create it when you insert data. 5 users.insert_1, user_data, inserts a single document, user_data, into the user's collection. 6 users.find_1, username, Alice_Wonderland, finds a document where the username field is equal to Alice_Wonderland. Returns a single document, or none if no matching document is found. 7 users.update_1, username, Alice_Wonderland, $set, age, 26, updates the document where the username is Alice_Wonderland. The $set, age, 26 part specifies that you want to set the value of the age field to 26. Other update operators like $inc, increment, $push, add to array, and $pull, remove from array, are also available. 8 users.find, finds all documents in the user's collection. Returns a cursor, which is an iterable object that allows you to iterate through the results. 9 users.delete_1, username, Alice_Wonderland, deletes the document where the username is Alice_Wonderland. 10 client.close, closes the connection to the MongoDB server. 5. Choosing the right database. Asterisk relational databases, SQL. Asterisk when to use asterisk. Asterisk when you need strong data consistency and integrity. Asterisk when your data has well-defined relationships and a fixed schema. Asterisk when ACID properties are crucial for your transactions. Asterisk when you need to perform complex queries and joins. Asterisk examples asterisk e-commerce platforms, financial applications, inventory management systems, systems requiring high accuracy of data. Asterisk no SQL databases asterisk. Asterisk when to use asterisk. Asterisk when you need high scalability and performance. Asterisk when your data is semi-structured or unstructured. Asterisk when you need flexibility in your data model. Asterisk when you are dealing with large volumes of data. Asterisk when you can tolerate eventual consistency, data might not be immediately consistent across all nodes. Asterisk examples asterisk social media platforms, content management systems, real-time analytics, IoT, Internet of Things, applications, mobile apps. Part 3, Connecting the Backend and Database. Now, let's integrate our simple Flask backend with a database. We'll use MySQL for this example, but the principles are similar for other databases. 1. Install necessary packages asterisk asterisk. 2. Example code, Flask and MySQL. Explanation asterisk. 1 From Flask import Flask, JSON IFA, request, imports necessary Flask components. Request is used to access data sent in HTTP requests. 2 From Flask_MySQLDB import MySQL, imports the Flask MySQLDB extension, which makes it easy to connect to MySQL databases. 3 AppConfig, configures the MySQL connection settings. Replace the placeholders with your actual MySQL username, password, database name, etc. 4 MySQL equals MySQL, app, creates a MySQL object, which represents the connection to the database. 5 At approot/users, methods equals get, defines a route for getting all users. 6 Cur equals MySQL.connection.cursor, creates a cursor object, which is used to execute SQL queries. 7 cur.execute, select asterisk from users, executes a SQL query to select all rows from the users table. 8 users equals cur.fetchAll, fetches all the results from the query and stores them in the users variable. 9 cur.close, closes the cursor. 10 return JSON users, returns the user's data as a JSON response. 11 at approot, /users, methods equals post, defines a route for creating a new user, using a post request. 12 username equals request.json username, extracts the username from the JSON data sent in the post request. Assumes that the request body contains JSON data like username, new_user, email, new_user at example.com. 13 cur.execute, insert into users, username, email, values, %s, username, email, executes a SQL query to insert a new row into the users table. The %s are placeholders for the username and email values. 14 mysql.connection.commit, important asterisk commits the changes to the database. Without this, the changes will not be saved. 15 return JSON message, user created successfully. Returns a success message as a JSON response. To run this example asterisk. 1 install Flask and Flask mysqldb asterisk pip install Flask mysqldb. 2 create a MySQL database asterisk create a database in MySQL, example using phpMyAdmin or the MySQL command line client. 3 create a users table asterisk create a table in your MySQL database with the same columns as in the SQL example earlier, user_ID, username, email, etc. 4 update the configuration asterisk replace the placeholder values in appconfig with your actual MySQL credentials. 5 run the application asterisk Python appy. Now, you can test the API endpoints using tools like curl or postman. Asterisk get all users asterisk. Asterisk create a new user, using post. Important considerations asterisk. Asterisk security asterisk never hardcode database credentials directly in your code. Use environment variables or configuration files to store sensitive information. Also, sanitize user inputs to prevent SQL injection attacks. Asterisk error handling asterisk add error handling to your code to gracefully handle exceptions, example database connection errors, invalid user input. Asterisk database abstraction, ORM consider using an ORM, object relational mapper, like SQL Alchemy to abstract away the details of interacting with the database. ORMs allow you to work with database tables as Python objects, making your code more readable and maintainable. Asterisk API design asterisk design your APIs following RESTful principles, using standard HTTP methods, consistent URL structures, and appropriate status codes. Part 4, Further Topics and Best Practices. Asterisk authentication and authorization asterisk implement proper authentication, verifying user identity, and authorization, controlling access to resources. Common techniques include asterisk JWT, JSON Web Tokens, a standard for securely transmitting information as a JSON object. Asterisk OAuth 2.0 asterisk a framework for delegated authorization, allowing users to grant third-party applications access to their resources without sharing their credentials. Asterisk caching asterisk use caching to improve performance by storing frequently accessed data in memory, example using Redis or MEMC8. Asterisk background tasks asterisk offload long-running tasks to background workers, example using Celery or RQ, to prevent blocking the main thread and improving responsiveness. Testing write unit tests and integration tests to ensure your backend code is working correctly. Logging implement logging to track events, errors, and debugging information. Deployment deploy your backend application to a production environment, example AWS, Azure, GCP, Heroku. Monitoring monitor your application's performance and health using tools like Prometheus, Grafana, and Datadog. Conclusion. This has been a comprehensive overview of backend development and databases. Remember that backend development is a vast and constantly evolving field. This tutorial is meant to give you a solid foundation to start learning and building your own backend applications. Continue exploring, experimenting, and building projects to solidify your understanding. Good luck.